Welcome! Today we're going to talk about the squeeze theorem. The squeeze theorem is a very useful method for showing that certain types of limits exist. Alright, the statement of this theorem is pretty easy and it looks very believable. It's easy to prove. If you have two functions that are sort of surrounding a third function, so f is always smaller, g is always bigger, and you have a function h in the middle, and you know that the two end functions, f and g, converge to the same thing. So the limit as x goes to a of f of x is L, and that's the same as the limit as x goes to a of g of x. Okay, so you have a little function and a big function, and they're both zeroing into L. Then, of course, the result is that, well, h, since it's trapped in between these, also converges to L. So this is called the squeeze theorem. All right, let's do an example with it. So let's look at the limit as x goes to 0, of x sine of 1 over x. All right, we understand x, no problem, straight line. But the sine of 1 over x is kind of tricky because as x is heading to 0, 1 over x is heading off to infinity. It's blowing up. And so 1 over x is zipping down that line, and so sine of it is just oscillating more and more rapidly. So this sine of 1 over x rapidly oscillates just back and forth between minus 1 and 1. So that's a very complicated, function. However, the limit isn't bad. So here we go. Let's notice that the sine of 1 over x, and this is true because it's true for anything, the sine of anything, the biggest it can ever be is 1, and the smallest it can ever be is minus 1. So that says that the absolute value of the sine of 1 over x is less than or equal to 1 always. All right, because it's between minus 1 and 1. Now, the absolute value of x is always bigger than or equal to 0, so I can multiply both sides by it, and it won't flip the inequality like it would if something was negative. So the absolute value of x times the sine of 1 over x is less than or equal to the absolute value of x. Let me combine these. X sine of 1 over x is less than or equal to the absolute value of x. Now, this statement just says that x sine 1 over x, that thing, since its absolute value is bounded by absolute value of x, the biggest it can be is sort of plus the absolute value of x, and the smallest it can be is negative the absolute value of x. No one writes the plus, of course, but whatever. All right, so here we go. This is a squeeze theorem scenario. We have our hard to understand function in the middle, and it's squeezed between two things that are easy, the absolute value and minus the absolute value. So we know by continuity that the limit as x goes to 0, and whether you have plus or minus, either way, the absolute value of x, that limit is 0. Since it's continuous, you can just plug in 0 and get the limit. So since the small function's heading to 0 and the big function is heading to 0, the squeeze theorem, ST, implies that the limit of the function in the middle, x sine 1 over x, has to be 0 as well. All right? That's an application of the squeeze theorem. Ciao.